All right, the next application of logarithms is the Richter scale, so how we measure the intensity of earthquakes. And again, this has a formula that we use. It says the Richter scale value is equal to the log of the intensity of the earthquake divided by this original intensity, I naught. So this I naught is just kind of this basic, very small earthquake that all other earthquakes are compared to. So when we say that the Richter scale of an earthquake is 6.7 for, let's say, that's just a certain number compared to, again, a very small base earthquake that we decided to compare everything to. This is not a linear scale. So if I say something is, a Richter scale 4, and then there's another Richter scale that's 8, it's not 2 times more powerful. This is a logarithmic scale or an exponential scale. So when we increase in intensity, it's tenfold or hundredfold or 1,000-fold more powerful than something small than it. So we'll kind of notice that when we do some of these comparisons. Okay, so in 2008 there was an earthquake in Rhodes, Greece. It measured 6.7 on the Richter scale. Express this intensity I in terms of I naught. So when we're done, our answer will be a comparison to this very small earthquake, how much stronger this earthquake in Greece was compared to this very small earthquake was. So they're giving us the Richter scale measurement, which means they're giving us this value right here. So I'm just going to set that equal to log of I. Again, I is the thing we're trying to find, and then I naught is this comparison. So this is a logarithmic equation, so I'm going to turn it into an exponential equation. And since it's a log, that means it's base 10. So I'm going to have 10 to the 6.7 equals I over I naught. So I'm trying to solve for I, so I'm just going to multiply both sides by I naught. So it means I equals 6, oops, that's not right, 10 to the 6.7 power times I naught. Okay, so let's figure out what this actually means. So this is the intensity of the Greek earthquake. So I'm going to label that I sub G. I'm going to bring up the calculator to figure out what 10 to the 6.7 power is. So 10 to the 6.7 power. All right. That would be 5,011,872. So about 5 million. This is a little, kind of an approximation to make a little bit more sense of it. So it's 5 million times stronger than I naught. So again, this very small base earthquake, this 6.7 earthquake is 5 million times stronger than it. Okay, so we can again see this is not a linear scale, but an exponential scale. This is a much, much more powerful earthquake than this basic earthquake we compare everything else to. All right, next one is similar type problem. So there was another earthquake in Sichuan, China, that measured an 8.0 on the Richter scale. I want to express this in terms of its intensity in terms of I naught again. So pretty much the same problem as last time. So set the Richter scale value equal to log of I over I naught. Again, we're going to try to solve for I, so we need to turn this into an exponential equation. Again, this is a logarithmic equation, so this is base 10. So I have 10 to the 8.0 power equals I over I naught. I naught over again. So I equals, and I'm going to call this I sub C, so China, 10 to the 8.0 power times I naught. Go back to the calculator. 10 to 8.0. So 1,000 million, 100 million. So 8.0 is 100 million times stronger than this base earthquake. Okay. All right, so the last part of this question is a comparison between these two earthquakes. How much more intense was the earthquake in China compared to the earthquake in Greece? So basically, we want to compare, like, what do we need to multiply the earthquake in Greece by? What's the intensity that we need to multiply the earthquake in Greece by in order to equal the intensity of the Chinese earthquake? Of course, if we have a question about multiplication, then really we solve that question by division. So I'm going to take the intensity of the Chinese earthquake, since it was the bigger of the two, divide it by the intensity of the Greek earthquake. We can actually just use the powers of these, so 10 to the 8th power divided by 10 to the 6.7 power. And we can throw that in the calculator. Let's be careful with our parentheses here. 10 to the 8th divided by 10 to the 6.7. So almost 20 times more powerful. So writing a short sentence, so the earthquake in China was about 20 times more powerful. Than the earthquake in Greece. So again, you see that this scale is not linear, that we had a change of 1.3 in Richter scale, but that was a change in 20 in intensity. So there is the Richter scale example.